Hello, everyone. Welcome to the fourth day of Digital Futures. I'm Liang Yi. In today's lecture, I'm going to walk you through the whole Lora training process and hopefully cover some of the details that would solve your confusion when using the LookX Lora training. Let's get started. Before we start to train a Lora, it's very important for us to set some expectation. What do I want my Lora to achieve? Is it a Lora about a specific object, or is it a design style or art style or something else? For example, we could train a Lora for pyramids and use it to generate images that has or is a pyramid, or at least pyramid-like. Or we expect the Lora to represent a design style that has multiple individual spherical building with large windows. These two training direction is the most common for Lora training. There are other goals that Lora could achieve, such as a concept or an attribute. For example, we all have some pictures in mind when thinking of cyberpunk. But if we really want to demonstrate the concept cyberpunk, we need to go beyond neon lighting, skyscrapers, and floating cars or something. To train a concept Lora, we want to have as many conceptual variants of the original objects as possible, which means that we want to have a cyberpunk bedroom, cyberpunk city, cyberpunk clothing, and even a cyberpunk mountain, and the list goes on, so that your Lora learns what cyberpunk is really about and how it could be applied to any other random objects. There are also some Loras that cannot be classified to be one of the above, but is usually more popular to use. For example, a low poly Lora that changes everything to be low poly art, a Lora to add details to images, or an age controlling Lora to control the age of people in the generated images. You might wonder how a Lora like low poly is different from a concept Lora, because it looks like a kind of filter or something that change everything generated into low poly. But here's a good explanation of what these Lora are capable of. So each row is generated with the same prompt and seed with only different Lora weights. And we could see that not only using positive Lora weights could affect the image generation. So going left, we have low poly images, or so with 1.0 is almost some color patches on the image. But going the other direction around, we go to negative 1.5. We have a very detailed images. So these low poly Lora is also capable of control the level of details of the generated images. So it's not basically a filter. It also learns about a latent concept of low poly or more poly. So after setting the expectation, we have to get our image data. I believe that you have heard of some basic rules, like the resolution should be larger than 512 times 512. Some other more subjective rules are more important, are also important. So your training images need to have better qualities, because I pointed out yesterday, it's impossible to caption all the attribute of an image. Simply put a keyword like low quality in the caption is not enough for the LoRa to learn the desired attributes of the training images. So except for single image quality, it's also important to have some quality consistency over the whole data set. Try to avoid overexposure, low contrast images. It's very likely that you won't remember to add these low quality keywords in your prompt, which means that your LoRa model will also learn them and or get unstable. Additionally, diversity is also important depending on the purpose of your expectation. If you want to train the LoRa for industrial design style bedroom, then it's definitely fine if you use the images from the left. But if you want to train the LoRa for industrial design style in general, then I recommend you to have diversified views of the images that share the same industrial design style. For example, you should have industrial design style bedroom, a kitchen, a living room, and a dining room, so that the LoRa learns more than just a bedroom. To sum up, these are the general rules for selecting images. It's better for the dataset to have consistent quality, diversified view, and well-diversified unwanted attributes. I will come back to it later. And it should have high resolution, and the image should have minimum details. So for the unwanted attributes, it refers to some attributes that is not relevant to your expectation of the LoRa. For example, the weather. If all of your training images are in sunny days and you don't really want sunny weather to be compulsory, then you should add some images of rainy and cloudy or foggy weather into your training dataset. And here are some experimental statistics or practice that I concluded for different training direction. If you are training a object, usually 10 to 100 images will do the job, and your caption would have to focus on captioning the view. For example, for a character, if this image of the character is a headshot, a portrait, or an upper body photo shoot, or a full body one. These rules are not necessarily the best practice, but will help you understand the difference of LoRa training. As for dataset, we have to keep in mind that copyrights for AI-generated images are still under active debates, so I suggest to treat it more carefully. Some open source image gallery includes Pexels or Unsplash, and there's a machine learning platform named Xkool that I highly recommend it. Also, your personal artwork or portfolio could be a good source for LoRa data. Also, Midjourney is famous for generating high quality images. So it's also a good way of getting consistent images around a topic. But Midjourney is not very good at architecture in general. So, but it's really good at other stuffs. After preparing the images, we need to caption the images. Basically, we just try to describe what is in each image with text. If you have used LookX, LoRa training, you probably have noticed the term trigger word. A trigger word is a rare token to represent the joint attributes of the training images. A common trigger word is OMX, because it doesn't have any meaning in most languages. A way to check if the token is rare is to put the token in the Stable Diffusion web UI and generate some images and see if it uses similar images or images of all kinds. Also, keep in mind that typos of simple combination of words are not rare tokens because they will be decoded into similar embedding as the correct words. And for the caption part, what you need to do is to write down everything you don't want the Lora to learn. So you can caption it in natural language or text. Here's an example of caption. And for the image on the right-hand side, the caption should include a trigger word and description of objects, lighting condition, visual effects, and weather. And you could definitely caption more details about the grass or the skies or so on. And that's it. However, for larger data set or just to make our lives easier, we usually use a auto captioner to begin with the captioning. Stable Diffusion web UI has built-in function for this captioner in image to image. You could paste the image in the tab and click interrogate clip or interrogate deep blue. And these are two different preset annotation model for captioning an image. So interrogate clip allows us to caption the image in natural language. For example, the image on the right will be automatically captioned to a concrete structure, blah, blah, blah. And Deep Blue caption the image with text, which is preferred by some users because it's easier to manually modify the caption later. This model is more frequently used for animation characters, but you could see that it is doing quite a good job for this specific image. After captioning all the images, we expect to see pairs of image and text file, and that's all we need for Lora training. As for the training part, I won't go into much details, and I would suggest you to take a look at this GitHub repository if you are interested. It has a great GUI that is similar to Stable Diffusion web UI, and you can train your Lora with interactive interface. As for the evaluation, when you are not sure about what parameters are best for your training purpose, you could use the XYZ plot of Stable Diffusion web UI we talked about yesterday to manually decide. Actually, the Lora training process is not a non-stop journey. You could dump a intermediate model every like 500 steps, for example. And if your total training steps is 3,000, then you will have 6 different Lora models or model snapshots so that you could compare each of them to decide how many steps is best for your training direction. Like I do here, I generated 6 Lora snapshots for one training and use different ways to compare the generation result. Here, my Lora is about a modern shopping mall design, and my training images are mostly in cloudy days. So basically, I would try to find a state where attributes are shown in the images, where all the attributes are shown in the image matrix here. And I felt that the image in the last column and second last row is the best, which correspond to 3,000 steps of training and 0.8 of LoRa weight. Okay, that's all for the LoRa training, and I would like to talk some more about your final group work assignment. If you haven't grouped up with the others, contact the group members or TA for support. In the final assignment, we expect you to choose 2 themes for creation. So the themes here is like an architectural narrative. You could choose your own topic of storytelling and your own media for presentation. It's highly recommended that you use a LoRa model you train to tell the story. Also, yesterday we talked about LoRa model evaluation system design, and that is also something we look forward to seeing. I will give you some inspiration for the final assignment. So this is one of the first LoRa's that I generated for no purpose. Actually, I just trained some artwork and try to generate some normal items that we can see in daily life. So a cake or a bowl of fruit. But with that artwork, LoRa, I can make it more like an artwork. So it's like you're creating some artwork from some normal product. And also, you may come up with something like this. It's like interior design, like a macaroon. So it wasn't decided before I trained the LoRa, but actually I felt like the final image looks like a macaroon, so I named it this way. Or you could place with different LoRa's and combine them together. For example, this is a Frank Gehry style building, but with some surreal rendering. And also you could have a Antonio Gaudi style villa or a church, which is pretty much the same as his work. And you could also have a surreal rendering of a city, which is just good looking. Or you could have some site plans made of fruit. Or maybe you could just have some like poster or commercial for fried chicken, but in a more fashionable way. Or you may just come up with some intricate patterns that's hard to explain. Or it's also possible that you want to create some artwork from your own home, maybe your garden or your school or something. So you may come up with images like this or this. Or more freedom or something. You can just create whatever you want. So play with the LoRa and the LoRa of others and create some unexpected artwork with these image generation technology. So that's all for today's lessons, and for